Hi everyone. So recently I posted a video and I explained how to calculate this algebraic expression, x to the power of 500 plus reverse of it if we have x2 plus x plus 1 equals 0. And this expression ended up becoming minus 1. And then one of the people asked me in comments, how come it becomes minus 1 when it seemingly is positive, because x to the power of an even number plus reverse of it definitely must be a positive number. And you are right if x belongs to real numbers. But as a matter of fact, here x does not belong to real numbers, but rather it belongs to complex numbers. It's a complex number. How come? If you calculate the roots of this equation here, so guys, here I'm not going to explain the complex number theory because that's a big topic. And here I assume you know a little bit about complex numbers. And if you calculate the roots of this equation, you get x equals minus 1 plus minus I, which is basically complex number, square root of 3 over 2. And it's clearly a complex number, and for that reason, yes, in the realm of complex numbers, it is possible to have such an expression, and then you get minus 1, even though it seemingly has to be positive. And then I explained in the comment of that video that, well, apart from the trick we used last time to calculate minus 1, there should be a different way to calculate this expression using complex number theory. And here I would like to solve the same problem using complex number theory. So we know from complex number theory that every, let's call it z, every complex number can be written as r to the power of r times e to the power of I alpha, where basically if this is the complex plane, let's call it, and this is the real value and y is the imaginary value, and let's say we have a complex number and this is x1 and this is y1 and our number is here. This is z. So we know that actually z can be looked at as a vector where the size of the vector equals to r. So r is the size of this and alpha is here. And if this is indeed the Euler formula, and if you expand this formula, you get r times cosine of alpha plus I sine of alpha. And absolute value of z equals to r. So if I try to find the other form for x, which is a complex number, then I will get the absolute value of x equals to this absolute value of this value 1 plus minus I square root of 3 over 2. So 2 comes out of it, and then here you get square root of 1 plus 3, which is 1. So in other words, the absolute value of x is 1. And if you want to find alpha, so let's write x again, expand it. It's minus 1 over 2 plus minus I square root of 3 over 2. So what alpha do you know which gives you these numbers? So let's look at again the plane, complex plane. If I have alpha as 2p over 3, so cosine of 2p over 3 is minus over 2, 1 over 2, and the sine of it is a square root of 3 over 2. And also there, because here we have two values, we have two roots for our equation, so another possibility is this angle minus 2p over 3, which basically it gives the same negative cosine and it gives a minus sign. So I can say 1 alpha, as a matter of fact, is 2p over 3, and 1 alpha is minus 2p over 3. So if I go back to the formula which I had, x equals to r e to the power of I alpha, we said that this is the Euler formula for every complex number. So we calculated r, it was 1. So as a matter of fact, here we get e to the power of I, because we have two possibilities, let's call it plus minus 2p over 3. And now if I want to calculate x to the power of 500 plus reverse of it, so basically it's easy. Then I have this value e to the power of plus minus I 2p over 3 to the power of 500, and then you get the multiplication of these powers, and then you have so we have here plus minus I 2p, and 500 divided by 3 is basically 166 plus 2 over 3, and I write it in that way. So this equals, we know when we have e to the, so basically you can expand it here. This is e to the power of plus minus I 166 2p plus, or sorry, times e to the power of plus minus I 4p over, sorry, 4p over 3. But this value is always 1. I'm sure you can calculate it. So x to the power of 500 equals this value, and that is, as a matter of fact, 4p over 3. Let's see how we can calculate that. So we can say e to the power of plus minus I 4p over 3, and so we can say that this is e to the power of plus minus I times p plus p over 3, right? So e to the power of I p, whether it is plus or minus, is always minus 1. So you get here minus e to the power of plus minus I p over 3. So we calculated this, and if you expand it, so basically you get minus cosine of p over 3. Here you get basically plus minus sine of I, you also have I p over 3. And then this becomes minus 1 over 2. Minus times plus minus is the same as plus minus. It doesn't really change anything. And a square root of 3 over 2. Interesting. And you also have I here. So this is what we get for I. And so let's go back to the same expression we had. We had, let's call it A equals x to the power of 500 plus reverse of it, okay? And we just basically substitute x to the power of 500 by this value which we calculated here, and then it becomes minus 1 plus minus I square root of 3 over 2 plus reverse of it, which is basically 2 over minus 1 plus minus I square root of 3. And now we just have to simplify this. So when we have a complex number in the denominator, basically we always, in order to simplify it, we always multiply both numerator and the denominator by the conjugate value of it. And because here I have two situations, plus and minus, and then the conjugate value will be basically minus 1 minus plus, minus for the plus when we have plus, and plus for when we have basically minus, I squared root of 3. So we are going to multiply both numerator and the denominator by these value, and then as a result we get a equals to minus plus I squared root of 3 over 2 plus 2 times minus 1 minus plus I squared root of 3. And for the denominator, so we know from the complex number theory that when we basically multiply a complex number by its conjugate, so what we get is basically 1 minus 1 times 3, which is basically 4. And this gives me, so that you can then simplify 2 here by 4, which basically gives me 2. And then what you get here is a equals to -1 plus minus I squared root of 3. And here again you get -1 minus plus I squared root of 3 over 2. And as a matter of fact, this always cancels this part, because for plus we have minus, for minus we have plus, and then you have -2 over 2, which is -1. So we basically proved using a different method why that expression a is equal to -1. So did you like the video? Please make sure that you like it and you share it with your friends, anybody who you think that enjoys watching this video. It helps me basically with my channel, and it helps with the YouTube algorithm.